Okay, good morning, everyone. Welcome to those online. It's the last day of Delta, and it's a three-quarter day, I guess. We finish at about 1 o'clock. We'll have a very short closing ceremony. Tanya will talk a little bit more about Auckland Delta coming up in 2 years, and then we've got pizza for lunch. So we have some wonderful talks this morning. It was really hard picking the timing and who talks when, and so thank you very much to those who are talking today. We have a slightly smaller crowd, but we really appreciate everyone coming and those talking today. It's a really exciting list of talks. To begin with, we are going over to Spain. Victor was out in Sydney last year for ICME for a good couple of weeks, and unfortunately couldn't come out to Delta this time. Victor's on the International Steering Committee, but we're delighted you can talk to us. Last night in Spain it is for you, so welcome to Mianji in Delta, Victor, and we look forward to hearing about your talk on AI, so we'll head over to you.
Thank you, Michael, for this nice presentation, and good morning, everyone in Australia. Well, my talk is about artificial intelligence in mathematical proofs, and my question is if it is reliable or not. Let me give a brief idea of my presentation. I will analyze the use of artificial intelligence in mathematical proofs, not difficult mathematical proofs, medium difficulty, and I will go to some theoretical framework, particularly the zone of proximal development, the ZPD. Probably you all know about it, and I will talk also about its possible adaptation to the use of artificial intelligence in mathematical education, and then some description of the methodology and the results. Let's go to the first part. Well, the ZPD is defined as the distance between the actual development level as determined by independent problem solving and the level of potential development as determined through problem solving under some adult guidance or in collaboration with more capable peers. As you can see here, it is very, very important in order to take advantage of the ZDP to have some an adult or people with more knowledge. This the MKO in order to can get the better results with the ZDP. You will always need an MKO person involved in the activity. So some researchers, for instance, McLeod, argue that perhaps the artificial intelligence can take the place of a person as the MKO. So in this very optimistic, enthusiastic vision about the artificial intelligence, they say that it can act as a very patient tutor. It is able to guide the student toward complex ideas. It can adjust the explanation based on the responses of the student. It also can help with tasks which are just out of reach, allowing the student to remain in the ZPD, adapt over time, learning from interactions, support the student at the right level of challenge, etc. So it seems to be fantastic, and perhaps it is, but let me ask the following. Perhaps all these characteristics are very nice, but I mean, ChatGPT can be very patient, can encourage a more active learning, etc. But this is almost unuseful if answers are incorrect. So my main question is about this, and I can pose this question: is it really the answers of ChatGPT or any artificial intelligence are equally reliable if compared with an experienced teacher? Well, in order to know if this is true or not, I propose a very simple proposition, which is, it was a combination of a theorem and a corollary of one of my book chapters, that it was released last year, at the end of last year. But when I performed this experience with ChatGPT, it was not available in the internet. The book was this one, Nonlinear Systems and Matrix Analysis, Recent Advances in Theory and Applications. It was published by Intech Open Science in London. So in the chapter 13 of this book, I propose the analysis of certain matrices that appear regularly in some chemical kinetics problems. These matrices has this form. I call them Focken matrices. This is an acronym, means first order chemical kinetics mechanism. And they have the following structure. All the entries, except the diagonal ones, all the entries are non-negative numbers, and the diagonal entry can be obtained adding all the others in the same column and changing the sign. So, for instance, take a look at this matrix. This is a Focken matrix. For instance, if we analyze the first column, we see 1, 2, 1, 2. If we add all of them, the number is 6. So -6 will be the number in the diagonal position. The same with the others. If we compute the eigenvalues of this matrix, the results are -6, 0 as a double eigenvalue, and 2 complex eigenvalues with real part -2. So it is easy to observe that all of them have non-positive real part, and this will be the main proposition that I proposed to prove to ChatGPT. And well, so formally, the property to be proved is the following. If A is a Focken matrix, that means a matrix with the structure previously described, then the real part of the eigenvalues are all less or equal than 0. Well, the proof itself consists on applying the Gauss-Gorin circles theorem to not to the matrix itself, but to the matrix, the transpose of the matrix. And the result is that all the eigenvalues lie in a disk centered in -r0, which radius r. So all the disk is located in the left part of the complex plane. So it is very, it comes straightforward that the real parts are all minor or equal to 0. The proof is very short, it's very simple. It can be considered just a corollary of a Gauss-Gorin theorem, taking advantage of the special structure of Focken matrices. And I also published another similar proof for other kind of matrices that can be easily adapted, and it was available in the internet. So the result itself was not available at that time, but there was something similar that also can be adapted. When I proposed the problem to ChatGPT, well, I say consider a square matrix with all entries non-negative, etc. Just in order that ChatGPT understands the proposition. As it can be seen here in the answer, you can see that ChatGPT understands because it writes again, in fact, the equalities with a different notation. However, it doesn't give any result about the eigenvalues. In fact, it comments on generalities and suggests the use of numerical methods. You can see it here. Therefore, the specific eigenvalues of the given matrix will depend on the matrix size and the values of the non-diagonal entries. Well, that means general things. And finally, he proposed the use of appropriate numerical methods. So nothing specific. So I try to guide ChatGPT in order to analyze the sign of the real part of the eigenvalues. So I ask it directly, what can you say about this sign? And ChatGPT says, again, general things. the sign of the real part of the eigenvalues can be determined based on the properties, so nothing specific. So this partial scaffolding process that I tried to practice, I tried to carry out with ChatGPT was not successful, at least in this first stage. So I insisted, and ChatGPT proposed a couple of statements, one about the trace and the other about the determinant of the matrix. The first one, the one about the trace, was correct. It says that the trace of this matrix should be negative. It is true. But the other one about the determinant, it says that it also will be negative. This is wrong. In fact, it is very easy to prove that this is wrong, because if we add all the rows of a matrix of this kind, you will get a row of zeros. So it's immediate that the sum of the rows get this result, and so the determinant should be 0. When I comment this to ChatGPT, the determinant is not a negative number since you can add all the rows, etc. ChatGPT admits the error. Apologies for the incorrect statement, blah, blah, blah. But it says nothing about the main problem, which is the sign of the real parts of the eigenvalue. So it seems that it still cannot solve the problem. Moreover, as we will see in the next slide, it says that it's impossible to make a statement about this issue. Let me show you. Therefore, in the given scenario, we cannot make a definitive statement. Well, I insist. I say, well, thank you for your response. I think that it is possible to prove that the eigenvalues have non-positive real parts. So I go straight forward to the thesis of the proposition. And I also comment, there should be a proof of this statement. And then it changes its opinion and says, yes, you are correct, I apologize. Allow me to provide a proof. The proposed proof, I will show you in the next slide, is incorrect, clearly incorrect from the very, very beginning. It says, we can consider the matrix A plus A asterisk. A asterisk represents the complex conjugate of A. So it proposes to consider this matrix, and it says that it's an Hermitian matrix, since it is equal to its own conjugate transpose. But this is false. In fact, if we use the same matrix I showed you a few slides before, we can perform the operations and we get this result for A plus A asterisk, and this other for the transpose, which is absolutely different. So the statement is false. When I remark this situation to ChatGPT, it tries again, and it says, well, that this is, we can write the eigenvalue equation in this way. Of course, this is false too. This is not the eigenvalue equation. The eigenvalue equation is like this one. And when all these inaccuracies of the new argument are observed, ChatGPT again recognizes the error. I apologize, you're right, blah, blah, blah. And then it attempts to provide a new pseudo-proof. And this is, it says, well, it proposes this equation for eigenvalues. This equation is correct, but when it says that we can consider the Hermitian conjugate of the above equation, it proposes one equation which is wrong. Once again, the incorrectness of this argument is remarked. This is my communication to ChatGPT. And again says, oh, yes, you are absolutely right. I apologize. And try to write another proof and makes exactly the same error that we saw in the previous slide. Well, so after all these errors, and particularly the exact repetition of the same mistake previously observed, I think that, of course, ChatGPT correctly understands the algebraic statement, but it is not able to provide a correct proof for it. Moreover, when I may continue questions and observations showing the incorrectness of these equalities, which is a certain form of scaffolding in trying to put ChatGPT towards the correct proof, well, the results are not positive. So let me go to some conclusions about these facts. Although I know perfectly that this is just a case study, it's not a statistical result with many propositions, it's just one proposition. Anyway, I think it is easy to identify some of the main characteristics of ChatGPT responses to this type of problems. Firstly, there's a certain tendency to give to answer with generalities, not giving specific results, just comment, or you should use numerical methods or these kind of things. In several cases, it proposes statements, some of them correct, like the one about the trace, and others clearly false, like the one about the sign of the determinant. It usually admits its mistakes. This is a good this is a good fact, I think. But it shows a certain inconsistency, since sometimes the artificial intelligence, I mean ChatGPT in this case, say that it is not possible to establish a statement, but then try to prove a certain statement. It repeats exactly the same mistake just a few lines after. And finally, I think that the attempts of performing some kind of scaffolding process that not seem to yield positive results in the artificial intelligence program attempts to provide a proof of the proposition. Well, if we observe all these features, I think the most worrying, at least from my point of view, is that maybe that ChatGPT is a patient MKO and is very helpful for the student and so on, but if it proposes incorrect statements, these possible advantages are not so good. So let me tell you that these incorrect pseudo-proofs were also reported by other authors, as I will comment, and usually they call them hallucinations, among other terms. Allow me to give some numbers. For instance, and Bandari, in a study with almost 300 participants, reported that ChatGPT can be comparable to human tutors, but with an effectiveness error of 32%. So maybe not the best human tutors if we compare with this result. Another one, Alonso Diaz reported a success rate close to 100% in integrals. That looks so good, but it drops to 80% in the resolution of differential equations. And going inside this topic, differential equation, Koxeska and collaborators reported an accuracy of 72% for first-order differential equation problems, and it drops again to 64% to second-order equations. So, as we can see, as soon as the problem becomes more difficult, more complex, the results are worse. From my experience, I think that it's reasonable to conjecture that ChatGPT effectiveness in providing original proofs, I mean, proofs that cannot be copied for the internet because were not published at that moment, would likely yield percentages even lower than those reported by other researchers in differential equations, integrals, and other topics. We can think in a very optimistic way that perhaps ChatGPT will improve on the other artificial intelligence platforms, will improve the results, as happened, for instance, with the chess playing machines, which nowadays they can play against several strong and human players. But let me remark that in chess, everything is finite, while in mathematics it is not. So in light of this, I think we can conclude that ChatGPT can be very useful in mathematics education due to several reasons. For instance, due to its speed, its easy of access to information, and because it produces also great motivation among younger students. However, its current limitations make the guidance of a human tutor absolutely essential. So it can help a human tutor, but not replace it, at least at the moment. So that's my talk. So thank you very much. And if you have any question, I will be very happy to try to answer. Thank you.
Yeah. Thanks very much, Victor. You're certainly very polite when you talk to ChatGPT.
Yeah, a little bit. When I talk about hallucinations, the other terms were not so polite. Some authors use the term bullshit, for instance.
Well, speaking of some swear words, as I live in the first year maths world, I'd never come across a fuck 'em matrix. So that's an interesting terminology, that one. There was a question that popped up from Kerry. What version of ChatGPT are you using?
The 3.5. When I used it for this purpose, it was 3.5. I know that nowadays we have better versions. Maybe they improved, but this is the result with that version.
Yeah, I was just going to say, Victor, have you tried version 5? Because they're saying that outperforms Wolfram Alpha.
Yeah, I suppose maybe as other software, other programs, if you use the version that is not free, I think they offer me the number 4 for free. I suppose the number 5 you have to pay for it, or maybe I am wrong. I don't know.
No, it's free. It's free.
It's free. Okay.
You know, it's free. It's free. And I mean, I suppose the other comment too is that thank you very much for your talk. It's really nice to see this work happening in these spaces. It's good in us looking at it and engaging and seeing what could and could not be possible. I think also too, there's a tension I think that we may need to address as a community is that AI stuff and any of the AI large language models are improving like right now as we're talking. They're just instant. It's really, really fast development. And then we have the other end of our spectrum where our research publication process is slow, and how that sometimes we might be getting things that are coming out in print that are going to be outdated before we've even finished penning them to paper. And how are we going to navigate that space as we move forward into this very much AI accessibility for AI and AI driven? What are your thoughts on that?
Yeah, well, I agree with you. Always. Well, I sent this paper for publication, and as you mentioned, when you send the paper, submit the paper, it takes several months or perhaps even more than a year in being published. And perhaps when the final work is published, the new version, or perhaps the 2 versions more were created. And this is a problem that we always have. Anyway, It's not so easy. I can check the version 5, but it is not so easy because, I'm not checking like other researchers, ChatGPT with, let's say, ODE problems or integral problems or whatever. I'm checking with proofs. And the problem with proofs is that if they are published, the only thing that ChatGPT or any other platform has to do is just to copy and paste. So I have to, I need to put something which is not very technical, not very complicated, but at the same time is not published in the internet. And then this is not very easy because there are many constraints. It should be something not very complicated, but at the same time, not so easy just to copy it from a web page and put it in the screen. This is not the idea. So perhaps when I have another paper which is almost to appear but is not published, I can check the new version.
Might be interesting just to see if the results are the same or not. Yeah, interesting. Anyway, thank you,
sure
Victor, very
it will be
much.
interesting. Yeah.
Thank you. Thank you.
Thanks, Kerry. Victor, there was just one question that popped up from David, recommendations. Do you have any recommendations based on what you found?
Sorry, again? You asking me for recommendations?
I'll just bring up David's question. Recommendations in respect of your findings.
Well, my main recommendation is that we as teachers, we can use ChatGPT and other tools as we can use any kind of technology, but it is not so simple that you can say, well, I can use a program like ChatGPT as an MKO, because if you are not sure that its responses are correct, correct in a very high percentage, you should be looking at the responses and that is control the process. Otherwise, our students will be confused by wrong propositions that seem to be okay, but for them perhaps it's not easy to see this. So I think it can be another tool to use, but no to replace. At this moment, this is impossible.
Okay, well, thanks very much, Victor, and let's thank Victor for his interesting talk.
Thank you very much, Michael, and thank you very much to all of you.
Thanks, Victor. We look forward to catching up with you sometime soon.
Yeah, I hope.